morning, students. Welcome back to science class on the chapter force. In the previous class, so we had discussed problems. So today also we will discuss. I think two or more problems are remaining. So later that I'll ask questions. So please answer for those questions in your comment box. Okay. Yes. First one. First I'll write the question. How much momentum will the dumbbell of mass 10 kg transfer to the floor. If it falls from a height of 80 centimeter, take its downward acceleration to be 10 meter per second square. Okay. Yes, I will give you 2 minutes time. So find the answer for this question and put it in your comment box. Okay. How much momentum will a dumbbell of mass 10 kg transfer to the floor if it falls from a height of 80 centimeter? Take its downward acceleration to be 10 meter per second square. Yes, quick. I'll give you 2 minutes time. Find the answer for this question. Fast. How much momentum will a dumbbell of mass 10 kg transfer to the floor if it falls from a height of 80 centimeter? Take its downward acceleration to be 10 meter per second square. Okay, here that dumbbell is falling from a certain height, right? So its initial velocity is equals to 0. Here we should take u is equals to 0. Why? Because see here, just now I will drop this one. Okay, so at that time, now here at this position, so before dropping, its velocity is equal to 0 meter per second. Okay, so that's why initial velocity is equal to 0. Next, acceleration they have given, so acceleration is equals to 10 meter per second square. Okay, and they have given mass of that is m is equals to 10 kg. Okay, and it falls from a height. Here they have given height, right? So that is height is equals to yes, right? That is 80 centimeter. 80 centimeter. So convert into meter because it is in centimeter, right? So that is 0.8 meter. Okay. So now here, how much momentum will a dumbbell of mass 10 transfer to the floor? You know, while touching, see, while falling down, so after some time it will touch the, it will hit the ground, right? So at that time, see that dumbbell, it will transfer its energy or its momentum into the floor. Okay. So here we need, so we should calculate the momentum of that dumbbell before touching the ground. To calculate momentum, we know the formula, that is P is equals to M into V. Here we know the mass of the object, but here we don't know V, right? So first calculate V. To calculate V, we have two formulas. Okay. So one is V is equals to U plus KT, and another one V square is equals to U square plus 2A. Yes. So and we know one more formula, S equal to UT plus half AT square. But here we can't use this one because there is no V. Okay. So better if you use this one, first equation of motion, but here you don't know time, right? You don't know time, so that's why you can't use this one. So better go with the third one. Here you know the V value, A value, and S value. Okay. Yes. So now use V square is equals to U square plus 2A. Yes. Okay. So already here we need V, right? Yes. So V is equals to 4 meter per second. Here Shruti answer. Yes. Wait. Let's check. Okay. Whether the answer is correct or wrong. So V square. So U value is 0 square plus 2 into 10 into 0.8. Okay, so 10 into 0.8. Here this is 0 plus 2 into 0.10, that is 8. Okay, then V square is equals to 0 plus 16. 0 plus 16. Then V square equal to 0 plus 6, that is 16. So V is equals to square root of 16. So V is equals to 4 meter per second. Okay. So before touching the ground, velocity of that object is 4 meter per second square. Yes, here Shruti, your answer is correct. Basanna Somanna, V is equals to 40 meter per second. It's wrong. Okay. By Nitin. Okay, yes, Nitin, your answer is wrong. V is equals to 40 meter per second. It's wrong. Okay, V is equals to 4 meter per second. So now calculate the momentum. Okay, so here we got the V value, right? So now calculate momentum of that object. Calculate the momentum of that dumbbell. First, yes, momentum of the dumbbell is M is equal to 40 meters. See, here you have used M is equals to 40 meter per second. It's wrong. Okay, P is equals to 40 meter per second. Okay, yes, answer is correct. 40 kg meter per second. Okay, the SI is wrong. Yes, so here we know the formula P is equals to M into V. So mass is 10 kg into 4. So that is P is equals to 40 kg meter per second. Okay, P is equals to 40 kg meter per second. Next one. Yes, so here from a rifle of mass 4 kg, a bullet of mass 2 times weight. Okay, so a bullet of mass 50 gram, a bullet of mass 50 gram is fired with an initial velocity of 35 meter per second. Calculate the initial recoil velocity of the rifle. Okay, so I'll give you 3 minutes time. So find the answer for this question. Calculate the initial recoil velocity of the rifle. Okay, yes, do it fast. Yes, Nitin Kumar here answered V is equals to 0.44 meter per second. Is it true? I think right. No, 0.44 is okay, but V is equals to minus 0.44. Okay, so here you should get that answer negative. Why? Because bullet is here. The bullet will move in one direction, and that rifle it is also moving in another direction, right? So both are opposite to each other. So that's why here you should get V value in negative. Okay. Yes, here Devika Kadagi your answered 40 meter per second. It's wrong. And next is Shruti answered V is equals to 0. No, here you should get V is equals to, you should get V value in negative. Okay, you should get V value in negative. Yes, see here. So I take mass of the bullet, that is 50 gram, right? 50 gram. That is 0.05 kg. Then its initial velocity. Initial velocity. See here. Here they have given what? Initial velocity. See, this is you can't take this as u. Why? Because see, this is the initial velocity after the collision. Okay, this initial velocity which is equal to after collision. After collision its initial velocity is 35 meter per second. Okay, so before firing both that bullet and rifle, before firing both the bullet and rifle both are at rest. Okay, so that's why initial velocity of the bullet at 0, and its the final velocity, that is v1 is equals to 35 meter per second. See here they have given what initial velocity. So this is the initial velocity after collision, after firing. Okay, when they fired at that time, its initial velocity is 35 meter per second. Here you should take this initial velocity as final velocity of the bullet. Okay, because this is initial velocity after firing, after collision. Okay, but before collision that bullet is at rest, right? So that's why its initial velocity u1 is equals to 0 and its final velocity is 35 meter per second. Okay, next I'll take mass of the rifle as m2, that is 4 kg, and its initial velocity I take it as u2. Here also its initial velocity is equals to 0. Okay, why? Because initially it is also at rest, right? Next I will take its final velocity as v2. So our work is to calculate the final velocity. Okay, yes, to calculate we know the formula, that is the initial momentum. Total initial momentum is equals to total final momentum. Okay, so m1 v1 plus m2, sorry, m1 u1, right? m1 u1 plus m2 u2, which is equal to m1 v1 plus m2 v2. So calculate the initial momentum. So that is m1 u1 plus m2 u2. Okay, so what is m1 value? Here m1 is 0.05 into 0 plus m2 is 4 into 0. So tell me what is the answer quick. So what is the answer first? Yes, first what is the answer? See here, 0.05 into 0, that is 0. Okay, and 4 into 0, that is 0. So 0 plus 0. So final momentum is, total final momentum is equal to 0. Why it is 0? Why? Because before firing, both that bullet and rifle both are at rest. So that's why the total momentum of the bullet and the rifle is equal to 0. Yes, here Shruti, initial, well, it's not initial velocity, it's initial momentum. Okay, it's initial momentum. Next, so calculate final momentum. M1 V1 plus M2 V2. So what is M1 value? So M1 is 0.05 into V1 is 35. Okay, plus M2 is 4, and we don't know it, right? Keep V2 as it is. Yes. So now multiply 0.05 into 35. So tell me what is the answer quick? 0.05 into 35. 0.05 into 35. Yes, 1.75. Correct. Okay. So 1.75 plus 4 V2. Okay, here we can't add, right? So now total moment, here we got a total momentum, that is 1.75 plus 4 V2. Now substitute here. So 1.75 plus 4 V2. Okay, so we need V2, right? Bring 1.75 this side. That is 0 minus 1.75 is equals to 4 into V2. That is minus 1.75 divided by 4 is equals to V2. Okay. Yes, so only three students are on the responding. One is Devika, and another one is Shruti, and one more Nitin. I don't know what about others. Okay. Yes, minus 0.4375 kg. Yes, correct. So here better into 100, then divided by 100. Okay. So V2 is equals to minus 1.7. Sorry, you multiply here, you will get 175 divided by 400. So you will get minus 0.44 kg meter per second. Even minus 0.437, even that is also correct. Okay. So here we got minus, right? So what it represents here, that if you fire from this direction, here bullet moves in this direction, then what about that rifle? That rifle, it will move in the opposite direction to the. See, it moves in opposite direction with respect to the bullet. Bullet is moving in this direction and rifle is in this direction. So that's why here the velocity we got a negative. Okay, so when you substitute this V2 value here, we will get to 0, because we need rate of momentum. Initial momentum is 0, then final momentum also should be equal to 0. Okay. Yes. Next one. Next one. Two objects of masses, two objects of masses 100 gram and 200 gram are moving along the same line. Along the same line and direction same line and direction with velocities of 2 meter per second and 1 meter per second. 1 meter per second respectively. They collide and after the collision, the first object moves velocity of 6-7 meter per second. Determine the velocity of the second object. Okay. Yes, here two objects of masses 100 gram and 200 gram are moving along the same line and direction. Both are moving along the same line and direction with velocities of 2 meter per second and 1 meter per second respectively. They collide. Okay, they collide. Why do they collide? Because here the velocity of one of the object is greater than the other one. So definitely both are going in the same line in same direction. So definitely we can say that. So both will collide. Why? Because here one object 2 meter per second, another one is 1 meter per second. Okay. Next one. They collide, and after the collision, the first object moves at a velocity of 1.67 meter per second. Okay. So first object moves at a velocity of 1.67 meter per second. Determine the velocity of the second one. So simple one. So here also we should use the law of conservation of momentum principle. First time. So I will write m1 is equals to 100 gram. 100 gram, that is 0.1 kg. Next, its initial velocity u1, right, and that is 2 meter per second, So I will take this as first object and its the final velocity is equal to 1.67 meter per second. So next M2, that is 200 gram. So 0.2 kg and its initial velocity U1 is equals to 1 meter per second. Sorry, U2, right? U2. So here we need its final velocity, that is V2. Yes, we know the formula M1 V1 M1 U1 plus M2 U2 is equals to M1 V1 plus M2 V2. Okay. Substitute the values. What is M1? That is 0.1 into 2 plus M2 is 0.2 into 1. Okay. Yes. First tell me the answer quick. 0.1 into 2 plus 0.2 into 1. Yes, first. Yes, Nitin for answer V2. You deleted. Okay, no problems here. This is 0.2 plus 0.2. So you will get 0.4. So the initial momentum is 0.4 kg meter per second. Substitute here. Okay. 0.4. Now capture final momentum. That is M1. Right here M1 value is 0. M1 is 0.1. Its final velocity is, that is 1.67 into M2 is 0.2 into, we don't know, keep V2 as it is. Okay, it just multiply 0.1 into 0.167 first. So when you multiply 0.1 into 1.67, so you will get 0.167 plus, right? Okay, so here you get 0.167 plus 0.2 into V2. So this is the final momentum. Okay, now substitute right here. So 0.167 plus 0.2 V2. Okay, so we need 0.167 plus 0.V2, right? Yes, bring 0.167 this side, then later divide that one by 0.2. Yes, so this is the, I'll give homework for you. Just bring 0.167 this side and then divide this one by 0.2. Okay. See tomorrow. I think see, this chapter is over. Tomorrow I will tomorrow I will allow live chat. In that live session I will ask questions. Okay. Hope maximum students will join that live session. Thank you.